So this last problem we just graphed, we found the slope of ln x at x equals 1. And that slope, we ended up finding from the graph, it looks very clearly that it's going to zero, going to a slope of 1. But if we let x go to 0 here, sorry, as h goes to 0, as x equals 1, we end up with a problem here because, well, I mean, we've ran into this problem before, but we end up with ln 1, which is 0, minus log 1, which is 0, over h. Okay, so that's 0 over 0, okay, when we let h equal 0. However, there's a bit of a problem in that the other ones we are able to somehow algebraically cancel out that divide by h. In this one here, this is actually a bit of a problem because we don't have an algebraic method to be able to do this. So we're going to have to rely on some other strategies here. And some other strategies are ones like we have some established limits, okay, that we can maybe use. We have some geometric arguments that we can use for these, but we need to use have some flexibility and apply other strategies to this. So we should know some of these established limits. Okay, so we can't find these ones algebraically. We had to kind of use either arguments or do geometric arguments for this. So sine x over x is one that we really should know. Okay, sine x over x, as x goes to 0, it's equal to 1. So this one here, this is 1 plus x to the power 1 over x. So this basically becomes 1 to the power infinity, because as we divide by x, we're going to end up with infinity. And that's going to be equal to e. Okay, so as x goes to 0, it's going to be equal to e. So you can see that as there's a hole there, but that value is at e. Okay, so I've graphed this one here. You can graph it yourself, but this is another one is good to know. Okay, this one's just another variation of this. And this one is set up as a compound interest problem. But as n goes to infinity, this is if we're dividing the rate by infinity, number of times we chop up that rate, and to the power of number of times we apply that rate, this actually becomes the compound interest formula. And if we have instantaneous compounding or continuous growth, we end up with base e. Okay, so this limit comes from actually compound growth. So this one here, if you take a look at it, the limit as x goes to infinity is going to be at e. So it approaches a value of e.